Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to build dependency graphs. Now, I just want to preface this video with saying we're not going to do absolutely any coding today. We need to go over this information. It's very important because I'm going to assume after this video you guys kind of understand, how data is laid out for the most part in my compiler. Of course, you can still always ask questions, but that's going to be assumption going forward. I also want to apologize for like the images. I know they're not the best, but I'm not an artist, so I did my best. So let's kind of talk about what do I mean by dependency graphs. Now, when it comes to dependency graphs, and by the way, when we get to the coding portion, we're not going to actually be building graphs. This is just a visual and a very high level representation of what we're going to be doing, but in a way, we will kind of have a dependency structure because of course we have to know where everything is in our compiler. So a dependency graph is going to consist of these three levels. You're going to have the platform level. And again, this is all written in Sharp. So like this is all of the various code that's written in Sharp and basically how each level depends on each other. So at the lowest level, you have the platform level. This is going to be the lowest level possible. This is like the start, the kernel of the actual programming language. Because once we start the programming language, like once the user executes main, there's a lot of code that's actually going to run before the user even gets to the main because we have to set up a lot of information. We can't just like start the function and it just works. That's not how it's going to work. So we have the platform level. We have the standard library. That's going to be your stuff like strings, integers and everything else. Then you have the user-defined code and libraries. So any code that the user defines beyond the standard library and the platform library, that's going to kind of be what the user's going to have. So let's see, what do we have next? Okay, so after that, here's like a brief kind of representation. Now, the size of these, like these squares don't really mean anything. I just kind of put a couple of examples of potential modules and libraries that we're going to have in our programming language. So we're going to have the platform library, we're going to have the kernel library, which is going to represent the start of our programming language. We're going to, of course, have the standard library, which, I mean, I guess this is a representative of everything else. This is actually going to be the biggest portion of our total code base, at least in terms of like the library, as far as libraries are concerned. And you can read the other ones. So these are just examples, but yeah, so let's go to the next one. All right, so we have a certain structure. We're gonna have to have a certain structure for how we lay out our programming language. And you guys absolutely are going to need to understand and do this before you actually write your language. Before you even write any code for the parser, this is a requirement. So the way it works is you have at the highest level, you have your module. And beyond that, you have what's called a global class. Now, the reason why we need a global class is because when you think about having a static field, what does that really mean, right? Like if you have a global field that's not bound by any class, it's just, inside of, a file and it's a global field, how do you have access to that field? How do you access that at the low level? You access that by accessing that inside of a class. Because when you think about it, if you have like a class called foo and it has a static variable of x, well, how do you access that static variable of x? You have to create an instance of foo that's separate from all of the other instances of foo. So it's going to be a singleton or what's known as a static reference. So when you have fields, you have to do the same thing. So we have to create a global class for that. This is extremely important. We're going to go over this a little bit more as the video progresses. Beyond that, everything that you have that is considered global is going to reside inside of this global class. So we're going to have in our global class, we're going to have our defined classes, our defined fields, and our defined global functions. So global fields, global functions, and global classes. So let's look at an example to kind of make some of this make sense. So here's a perfect example. You have this main function, and it's a global function, right? Like it's not inside of a class, it's just in this module inside of this, well, the file isn't showing in this image, but the way it's laid out is it's inside of the main module. As you can see, it's inside of the SRT global class. This is going to be a global class that is created under every single module to represent the static data or, static instance of whatever we have. Then, of course, we have the main function. So theoretically, in the compiler, you could literally type, it's completely unnecessary, but you can literally type main hashtag srt global dot main. and that will basically access this main function. But that's very cryptic. You don't really need to do that. You can just call main and it'll just work. So let's look at a different example. In this example, we have, our main module, we have a class and then a function. So if we look here, we will have our main module, our SRT global class, our foo class, and then our work function. So that's going to be a visual representation of how the dependency graph would look if we were to blow it up into a visual representation. So I'm pretty sure you guys have caught on, but as you can see, for every single module, there will be a subsequent SRT global class created. And that's totally fine. We can do that because classes are defined by modules. In our programming language, each module, you can have the exact same named class, but so long as that it's residing inside of a different module, it's totally fine to have that. Now, I know some of you are probably wondering, well, how do we figure out where things are? I mean, obviously this has to be like a dependency nightmare, right? Like if we have all these SRT global classes and, we're trying to resolve a field called foo, and let's say, this field foo is inside of this module and it's also inside of this module. Well, how do we figure it out? Like which one are we going to pick here? In that case, the user is going to have to use a direct module access. So they're going to have to say std.io hashtag foo or platform hashtag foo. Or they could even, if they want to be really cryptic, stdio hashtag srt global dot whatever they're trying to access. So that's kind of how that's going to work. Again, very important. You absolutely need to have this. So let's talk about ownership versus inheritance. This is a pretty interesting one. So let's just kind of see what that means. So when it comes to ownership and inheritance, they're two completely different things. So you have a class that basically resides inside of another class. That's considered ownership. And then you also have inheritance, which basically represents a class inheriting values or high-level constructs from a different class. So in this example, this is an example of ownership. So the foo class is defined, so we're going back to our foo example here. The foo class is defined at global scope, meaning that it's going to be inside of our SRT global. And by the way, SRT is short for sharp runtime. So if any of you guys are wondering, but SRT global, it's going to be inside of there. And this represents that this class owns this user-defined class in the same vein that this module owns this SRT global class because it's defined under this module. So this module effectively owns that class. Same thing with the work function. The work function, functions have to be defined and constrained by a class to be called and accessed, and they have to have an instance to call and access it on. So because of that, the work function is owned by the foo class instead of the SRT global. If we took this and put it in the global scope, then of course this would own it. Let's keep going on. So here is a basic kind of visual representation of how ownership and inheritance works in Sharp. Well, I guess inheritance. Well, we've already kind of talked about ownership. So inheritance works as follows. You have a defined class, you have defined fields, functions. Now, I didn't put everything in here. I think you guys kind of get the point, right? Obviously, we have other things in our language, like we have constructors, we have operator overloads, we have aliases. I don't think I need to put, everything in here to like prove a point. Like I'm just showing you that these items are owned by this class, and inheritance comes in when we have what's called a superclass. Superclasses are classes where you inherit some class as a base class. So that's what the S is for. And then these are what's called interfaces. So interfaces are kind of like on the side. You're not really directly inheriting interfaces because at the low level, inheritance is completely different than implementing interfaces. Like implementation of interfaces and class inheritance at the low level are two separate things. So we absolutely need to separate them. So let's kind of look at a more concrete example of how this works. So I wrote up a quick example, and this is going to kind of explain how my compiler sees all of this information. So we have a class. Now, I apologize for the names. I know they're bad. I couldn't come up with better names than this. So we have FIFU as one class. We create an interface called ifoo, and then we have our final class called foo that inherits FIFO and implements IFO. It's going to have to implement the methods in IFO. Now, I know I didn't write any functions in IFO. We'll go over how interfaces work with classes in a later video. It's a little bit complicated, and I don't want to like make this video too long. But as you can see here, we have our main method or our main module. Of course, we have our SRT global class. Then we show inheritance versus ownership. So these two lines mean that FIFO and FOO are both owned by the SRT global class. However, FOO inherits FIFO. It also implements the functions defined in IFO. And you can also see here that IFO is also owned by SRT Global. And then of course we have our work function, which is owned by FOO. So you can kind of see the differences between inheritance and ownership. They do matter because once we get to resolving all of these classes and functions and interfaces and stuff, we're gonna have to know that, like, if, for instance, if we're inside of the foo class, right? Well, what functions, fields, and aliases does the foo class own? Because of inheritance, effectively what happens at the low level is this foo function takes everything from FIFO in terms of inheritance and it becomes one class. So at the low level, we have no concept of, now, I mean, we still do, I still hold on to a loose representation of what inheritance versus ownership is at the low level when we get to our virtual machine. But in terms of memory mapping, like when we map out our classes into memory, every field, function, and everything else defined inside of FIFO becomes a part of foo, as if those functions were originally created in that class. So I don't want to get too deep into the weeds with that, but that's kind of how it works. Let's see, do I have any more? Okay, so that's it. So that's going to be it for today. Hopefully that made sense. If you guys have any questions, definitely put them in the comment section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidfc/sharp. And when you do, definitely watch, start, and fork this repository. That's going to give this repository a lot more visibility and let other developers know this language exists. Also, if you guys are curious about maybe some of the things that I've been doing on a daily basis, you can head over to the remastered branch and you can check out the commits. You can kind of get a gist of what I've been up to without really having to look too deep into the code because I write some pretty wordy and in-depth detailed commits. Also, if you're curious about maybe learning some of the things that I've done in the past or maybe stuff that I'm looking to add to the language in the future, you can head over to the docs folder and there's two main files. You can check out the changes file. This represents all of the old past releases that I've had with my language. And the roadmap file represents pretty much everything not only have I done in the past, but also stuff that I'm looking to add in the future. So that's going to be it for today. As usual, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.